किंवा पुढच्या डिग्रीलाही तुम्ही जेव्हा जाल तर मेटलची सगळी असतो पुढे. तो महत्वाचा पार्ट दॅट इज टोटली डिपेंड अपॉन दिस आयन कार्बन इक्विलिब्रियम डायग्राम. That we will understand basically from start again. Screen share झाले स्टुडंट्स? स्क्रीन शेअर करायला पाहिजे. स्क्रीन शेअर झाले स्टुडंट्स? Students, am I audible? आवाज येतोय का माझा? हॅलो स्टुडंट्स, आवाज येतोय का माझा? आपण आयन कार्बनिक क्लोराईड शिकतोय. जस्ट अ मिनिट. स्क्रीन शेअर करतो पहिल्यांदा. स्क्रीन शेअर झाला का स्टुडंट्स? So we are studying iron carbonic chloride diagram. Basically, in that diagram, there are different parts. Basically, the diagram shows the entropy of iron. Entropy of iron means that diagram shows the different phases at different temperatures. There are different temperatures structures. So, this is like iron carbonic chloride diagram. So, iron carbonic chloride diagram having different crystal structures.
Anion carbon diagram.
व्हिडिओमध्ये बघू.
Anion carbon diagram. Eutectic. Eutectoid. Pearlite and cementine. Austenite. Ferrite. Pearlite. Pearlite and carbide. Steel. Cast iron. Outline introduction cooling curve for pure iron. Definition of structures. Iron carbon equilibrium phase. The iron carbide diagram. Explanation. The austenite to ferrite cementite transformation. Nucleation and growth of pearlite. Effect. Percentage on the microstructure of steel. Relationship BWC percentage and mechanical properties of steel. Cooling curve for pure iron. Definition of structures. Various phases that appear on the iron carbon equilibrium phase diagram are as under: austenite, ferrite, pearlite, cementite, martensite, liberite, unit cells of various metals. Figure the unit cell for A. austenite, B. ferrite, and C. martensite. The effective percentage of carbon by weight on the lattice dimensions for martensite is shown in D. Note interstitial position of the carbon atoms and the increase in dimension C with increasing carbon content. Thus, the unit cell of martensite is in the shape of a rectangular prism. Microstructure of different phases of steel. Definition of structures. Ferrite is known as alpha solid solution. It is an interstitial solid solution of a small amount of carbon dissolved in alpha BCC iron. Stable form of iron below 912 degrees C. The maximum solubility is 0.025% C at 723 C and it dissolves only 0.008% C at room temperature. It is the softest structure that appears on the diagram. Definition of structures. Ferrite. Average properties are: tensile strength equals 40,000 pounds per square inch. Elongation equals 40% in 2 in. Hardness greater than Rockwell C0 or greater than Rockwell B90. Definition of structures. Pearlite is the eutectoid mixture containing 0.80% C and is formed at 723 degrees Celsius on very slow cooling. It is a very fine plate-like or lamellar mixture of ferrite and cementite. The white ferritic background or matrix contains thin plates of cementite, dark. Definition of structures. Pearlite. Average properties are tensile strength equals 120,000 pounds per square inch. Elongation equals 20% in 2 inches. Hardness equals Rockwell C20, Rockwell B95 to 100, or BHN 250 to 300. Definition of structures. Austenite is an interstitial solid solution of carbon dissolved in FCC iron. Maximum solubility is 2.0% C at 1130 degrees Celsius. High formability. Most of heat treatments begin with this single phase. It is normally not stable at room temperature, but under certain conditions it is possible to obtain austenite at room temperature. Definition of structures. Austenite. Average properties are tensile strength equals 150,000 pounds per square inch. Elongation equals 10% in 2 inches. Hardness equals Rockwell C40 approx. And toughness equals high. Definition of structures. Cementite or iron carbide is very hard, brittle intermetallic compound of iron and carbon, as feet, contains 6.67% C. It is the hardest structure that appears on the diagram, exact melting point unknown. Its crystal structure is orthorhombic. It has low tensile strength, approximately 5,000 pounds per square inch, but high compressive strength. Definition of structures. Liperite is the eutectic mixture of austenite and cementite. It contains 4.3% C and is formed at 1130 degrees Celsius. Definition of structures. Martensite, a supersaturated solid solution of carbon in ferrite. It is formed when steel is cooled so rapidly that the change from austenite to pearlite is suppressed. The interstitial carbon atoms distort the BCC ferrite into a BC tetragonal structure, BCT, responsible for the hardness of quenched steel. The iron carbide diagram. No matter the temperature at which different phase changes result in very slow heating and cooling in relation to carbon, is called iron-carbon diagram. Iron-carbon diagram shows type of alloys formed under very slow cooling, proper heat treatment temperature, and how the properties of steels and cast irons can be radically changed by heat treatment. Various features of phase diagram. Phases present. L. A ferrite. BCC structure. Ferromagnetic. Fairly ductile. D. BCC structure. Paramagnetic. G-austenite. FCC structure, non-magnetic, ductile, feet cementite, orthorhombic, hard, brittle, reactions. Peritectic L plus T equals G. Max. Solubility of C in ferrite equals 0.022%. Max. Solubility of C in austenite equals 2.11%. Eutectic L equals G plus feek. Eutectoid G equals A plus feek. Three-phase reactions. Peritectic at 1490 degrees C with low weight percent C alloys, almost no engineering importance. Eutectic at 1130 degrees C with 4.3 WT percent C alloys called cast irons. Eutectoid at 723 degrees C, two-phase mixture, ferrite and cementite. They are steels. How to read the phase diagram. Eutectic, eutectoid, pearlite and cementine, austenite, ferrite, pearlite, pearlite and carbide, steel, cast iron. The iron carbide diagram. Diagram shows three horizontal lines which indicate isothermal reactions on cooling, heating. First horizontal line is at 1490 degrees Celsius, where peritectic reaction takes place. Liquid plus common left right arrow, austenite. Second horizontal line is at 1130 degrees Celsius, where eutectic reaction takes place. Liquid left right arrow, austenite plus cementite. Horizontal line is at 723 degrees Celsius, where eutectoid reaction takes place. Austenite, left right arrow, pearlite, mixture of ferrite and dye. Delta regional ferrite diagram. Liquid common left right arrow, austenite. Ferrite region of ferric carbide diagram. Simplified iron carbon phase diagram. Austenite, left right arrow, mixture of ferrite and cementite. The austenite to ferrite cementite transformation in relation to phase C diagram. The austenite to ferrite cementite transformation in relation to phase C diagram. In order to understand the transformation processes, consider a steel of eutectoid composition, 0.8% carbon, being slow-cooled along line XX. At the upper temperatures, only austenite is present, with the 0.8% carbon being dissolved in solid solution within the FCC. When the steel cools through 723 degrees Celsius, several changes occur simultaneously. The austenite to ferrite cementite transformation in relation to phase C diagram. The iron wants to change crystal structure from the FCC austenite to the BCC ferrite, but the ferrite can only contain 0.02% carbon in solid solution. The excess carbon is rejected and forms the carbon-rich intermetallic known as cementite. Pearlitic structure. Finite reaction at the eutectoid is the formation of pearlitic structure. Since the chemical separation occurs entirely within crystalline solids, the resultant structure is a fine mixture of ferrite and cementite. Schematic picture of the formation and growth of pearlite. Cementite. Ferrite. Austenite boundary. Nucleation and growth of pearlite. The austenite to ferrite cementite transformation in relation to phase C diagram. Hypoeutectoid steels. Steels having less than 0.8% carbon are called hypoeutectoids.
स्टुडंट ठीक आहे रिमेनिंग पार्ट आपण पुढच्या लेक्चरला बघू ओके स्टुडंट लेक्चरची वेळ झाली पुढच्या कारण विल स्टॉप ॲट हिअर सो रिमेनिंग पार्ट विल सी ॲट द नेक्स्ट लेक्चर सो यू कॅन रिमूव्ह फ्रॉम द लेक्चर थँक्यू स्टुडंट्स बाय